Okay, so let's take a look at the allowed energies for your particle in a sphere. If you did solve the Schrodinger equation, you get your size, you'll find there the spherical harmonics. You can find that the energy is quantized, and the quantization of the energy depends on quantum number L. So this is L times L plus 1 times h bar squared over 2I. And just as before, we're going to abbreviate h bar squared over 2I by capital B here. You call that the rotational constant. Remember what I was? I is just mr squared, the moment of inertia. So energy is quantized since L is restricted to 0, 1, 2, 3, 4, and so on, non-negative integers. So what would our energy level diagram look like? What are the allowed energies? What's the lowest allowed energy? L equals, so let's look at the table of, let's make a table of L, M sub and M, right? And the energy. So L is 0, M can be 0. What's the energy? 0 times 0 plus 1 times B, which is just going to be 0. So this is L equals 0, M equals 0. What's the next possible value for L? 1. But if L is 1, there are 3 possible values for M. What are those? Plus 1, 0, and negative 1. So you can have 1, we can have L equals 1, M equals plus 1. You can have L equals 1, M equals 0. And you can have L equals 1, M equals negative 1. So there are 3 possibilities where L equals 1. What's the energy for these 3 quantum states? So that's L, which is 1, times L plus 1. So that's 1 plus 1 times B. Okay, let me separate this. And that's going to be equal to 2B. So the first excited state would be 2B. So this is 0. First excited state would be 2B. How many ways can your system, can your particle on a sphere have an energy equal to 2B? 3 ways. Okay? So we say the degeneracy of this energy level is 3. So you have 1 plus 1, 1, 0, and 1, negative 1. What's the next energy level going to be? For L equals 2, what are the possible values of M sub L? Plus 2, plus 1, 0, negative 1, negative 2. It doesn't matter what order I list them, okay? So 2, 2, 2, 1, 2, 0, 2, negative 1, and 2, negative 2. What's the energy of these quantum states? Energy here would be L, which is 2 times 2 plus 1 is 3 times B, 6B. So the next energy level is going to be 6B. What's the degeneracy of that level? So that's 2. Degeneracy of that level is 5. So 1, 2, 3, 4, 5. There's 5 quantum states that correspond to that amount of energy. What are those? 1 plus 2, 2 plus 2, 2 plus 1, 2, 0, 2, negative 1, and 2, negative 2. So, what's the next energy level going to be? For L equals 3, what's the energy for L equals 3? 12B. And what's the degeneracy of that level? 7. 7 quantum states. And those correspond, so all of these for L equals 3, M sub L going from plus 3, plus 2, plus 1, 0, negative 1, negative 2, and negative 3. So in general, what's the degeneracy of each level? It's going to be 2L plus 1. Okay. So you say it's 2L plus 1 fold degenerate, each allowed energy level.